Hi, this is Boatfish. It's been a while. Okay, so, hear me out. Underground horse storage. So, like one of those underground bike storage areas you see like in Tokyo, where it's like a small station above ground, you push your bike inside, and then the platform descends and stores your bike in this underground circular vault along with other bikes. I'll put an image on the screen. But anyways, I don't really know how this will go, because I'm not the best at Redstone, so we'll see. Let's get started. So this is the main idea for the entire storage system. We have one row where all the horses will be lined up in individual units, and then the other row will be for the flying machine to pass by and push the horse back and forth. So for each individual unit, there'll be a pair of double piston extenders to push the horse from the holding chamber into the flying machine row, where then if I activate this flying machine, we'll bring the horse to the front of this entire corridor, where there will be another flying machine at the bottom to push the horse up to the surface. On the other hand, to return the horse back to the storage system, we have the flying machine activate again to bring the horse back into the area. We have this piston lock to align the horse with its storage area, the one that we choose, and then we just do the reverse. We have the double piston extenders push them back into the chamber, just like that. On a side note, this device above the holding chamber is really important as it helps me detect if there's an entity within this storage area or not. You can see it's literally a piece of string attached to an observer. So if I simulate withdrawing the horse by activating the pistons like this, you can see that the horse has gone from an in state to the out state. So there's nothing in here. I can safely deposit another horse if I need to. And obviously if I just deposit the horse back into the station, you just push and pull, and then now the horse is back in. This is important because I don't want to have any like entity collision, just having multiple horses in the same lane, or just breaking the system in general, basically. Onto the flying machine. So this flying machine works on the idea that if it hits an obstacle, it goes back in the opposite direction. So how does it work? Traditionally, flying machines work on this push-pull mechanism. This piston pushes, this piston pulls, and then it just goes forward block by block. And then, if it hits an obstacle like this piston pulls, this tries to push, but it can't because there's an obstacle at the front. So this redstone map is really important because it has a certain amount of delay. When this piston pushes, it basically ends the cycle, right? However, because this has an amount of delay, after it's been pushed and sort of activates, it reactivates this observer facing into this piston, which then pushes and then makes this one pull again. So now this push, this pull, and then it returns back to the original position. That's how it goes back and forth. This is especially important in this sort of context because if I want to withdraw or deposit multiple horses at the same time, then, well, if the flying machine is at the front, just stuck here, I can't really tell it to withdraw another horse because I have to tell it to go back and then go and push another one to the front. So it just has to reset to make the circuit a lot more easier. One more thing. Apparently, if you place this obsidian next to this empty block over here in the flying machine, it just goes back and forth indefinitely, not just goes back and then stops, which I don't know how this happens, but it's another feature, so it's pretty cool. Funny how I made a clip dedicated to explaining the flying machine and how it goes back and forth automatically when I don't actually need that, because I figured out that you actually have to return the platform back to the original spot before withdrawing another horse, because like what are you going to do if the platform's still up there? It's just going to have another blockage, right? So here is something I've built to sort of align the platform with the respective stall. You can see it's not very compact. I've tried to make it as compact as possible, but so you have this sort of like lock. When you activate this unit, it locks like this, and then if I activate the flying machine, you see I'm using a comparator, a compositor, to activate a comparator, which then sends a signal to lock this unit like that. And then when it comes back, then obviously like the same thing happens as with the explanation like, I don't know, 2-3 clips ago, just like that. A small progress update. I just finished the vertical flying machine, and here's a small demonstration of how it works. So when the horizontal flying machine pushes the platform to the front, you sort of have to assemble the flying machine because I left a small block gap here, so once this flying machine moves, it doesn't pull the piston along with it, with the honey block platform. And well, this works because the slime blocks and the honey blocks will stick to and interact with any blocks it's stuck to, but the piston doesn't. So you can just push the piston whenever you want, like that. Okay, we activate the flying machine, goes up into this, the holding chamber. Well, the actual withdrawing chamber, sorry. And like, realistically, once this is finished, all 4 walls will be sealed up so the horse can't fall. And once you're done with throwing your horse, you push the button and it goes back down. Like that, and then disassemble the machine. And send this thing off, just like that. This is the second test of the system that allows the flying machines to go up and down, back and forth. So there actually was another system before this, but I accidentally demolished it because it didn't work before I recorded it. So here goes nothing. So you have this flying machine going into the dock. The vertical flying machine goes up, which is good. The first half is already good enough. And then goes back down. Let's see. Nice. It works. Yay. Just a small addition, but I added this orange circuit so that it activates the lock, this lock above here, when one of the little piston extenders here activate when it pulls the honey block across or back. So basically what this does is it streamlines the process, so you know that if this piston activates, the corresponding piston here activates, and so the corresponding lock for that unit will also activate. This makes it easier, but point is that this thing, these 7 blocks, took me at least an hour. It's supposed to be easy, but I just don't know what happened there. I thought it would be useful to explain the different iterations of the same circuit. So the circuit I'm going for is that the point is, I don't want to create a loop. If I send a signal from this side to the other side, you know, the 2 sides of the system, you can see that both up and bottom light up. But if I send a signal from the other side back, it only lights up the top and not the bottom, because I don't want to create a loop and it loops back and loops back. It just doesn't make sense. And so the first mechanism is that redstone can travel down half slabs. You can see that if I activate this, this is at the bottom, right? So the redstone can go up. But over here, this observer powers the top, and it can't travel down these half slabs, so it doesn't power the bottom. On the other side, we used hard powering and soft powering. So from this side, you can see the repeater will hard power this block, which will hard power this redstone dust, which soft powers this block, and then the redstone can just take an output from that. On the other side, however, this observer again is powering the top, but then this redstone dust, it can't reach down here because it's soft powering this block, which can't reach to this redstone dust, so only the top activates. Eventually I decided on using these redstone half slabs just because they're a lot more simple compared to soft or hard power, because that uses redstone, repeaters, more blocks, and it's just a lot more complex compared to just redstone dust and a few half slabs. Anyways, I've now finished the individual unit and now it's all working automatically, and I've also cloned everything to 15 just because, well, redstone signal strength maximum is 15, so might as well just make 15 storage units, right? But while cloning, I have made this one block, extend this block one out just because it didn't work due to some redstone torch powering issues, so unfortunately it's not as compact as before. So yeah, now to the final part of the video and the system, where I need to make 2 sort of decoders. The first decoder, below here, will be to select which unit I want to use, and the other decoder will be up here to tell me if there is any horse in the storage unit or not, with this string observer mechanic. And speaking of these decoders, this might be the hardest thing in this video yet, just because I can't imagine it. I can think of a way to sort of brute force it by using item filters, but that's just a bit too bulky, so I'll figure it out, I hope. It turns out the first part was pretty easy. I mean, you'd expect a person who made a video on it to know what he's doing. But anyways, I've added this orange circuit. So originally how the lock worked was that if you turned off one of these redstone torches, the piston would deactivate, and then it would allow the signal to flow through this monostable circuit like that. But now that's not the case. You can see the circuit will Well, one of them is turned off out of all of these redstone torches to show this is selected. And then there's this entire comparator tower, goes up to the top. You can see, like, if I just maybe select number 6 or something. Yep, you can see like the pistons moving, and now the 6th module is selected, it's deactivated. It's not shown there. Also, I don't know how Wandering Trader got inside. I mean, it looks like he's doing well. Since the last clip, I've added a few more miscellaneous things, which include these 2 redstone towers and a redstone line, but which specifically this is a lock, which disables your ability to reselect and reactivate different modules while the machine is running. Just because, like, if you activate multiple modules while the machine is running, you might withdraw multiple horses and then like lead to a honey block blockage, and then it breaks the machine. Not very ideal. But anyways, I'm proud to announce that this thing is functional. I'm able to withdraw, deposit, select, activate this entire system with these 2 buttons and a lectern above here. This decoder I was mentioning before, I will make this later, but this isn't necessary for the functionality of this machine. It's more of a quality of life thing, just because I need to be able to see if a unit is empty or not if I want to withdraw a horse. But anyways, let's get on to the decoder. Hopefully the last explanation of this video. So decoders work by analyzing different signal strengths in order to separate different modules of the same system. In front of me I have 2 different circuits, and these 2 circuits are really important if you want to know how to manipulate and transport these circuits to the main decoding system. So basically everything to do with signal strength. So you can see that these 2 circuits are similar in a way that they have 2 comparators spaced 2 apart. However, one has redstone dust and a block, while the other has 2 redstone dusts. Now this circuit will be able to diminish the redstone signal to differentiate it, and this carries the signal strength over, so it's the same signal strength throughout. So how does it work? Imagine we have a 15 signal strength here in this redstone dust from this repeater, right? And then this comparator will output 15, and then it goes down 1 as it travels a block, 15 to 14. This comparator inputs 14, then outputs 14. So eventually this goes from 15 down to 0. That's easy, right? For this one, we have a block in a redstone dust. So imagine again, this is 15. The comparator will receive 15 and output 15 to this block, which then this redstone dust will also output a 15, and then this comparator will input 15 into the block, 15, and then just carries on the same signal strength. So that's how you differentiate between these 2. You might be wondering, Bloatfish, what happened to the lovely checkered floor you had down here? Originally there was a checkered floor where you could place a block between these repeaters and the signal will still go through, and so it would save redstone. However, I didn't do much research into horse AI, and if you look over here, horses can actually jump down a certain number of blocks. Ignore that letter down there. So if you see these 3 platforms, well, 2 blocks tall, and already the horse just jumped off. But this horse on the 3 block platform has not jumped off. And then by removing that extra block, the horse will actually stay on this honey block platform. So unfortunately, technically you could lower this, but I just choose not to. And there we go, the entire system is finished. We have this visual display panel to see if a unit is empty or not. Now you can see that unit number 3 has a horse in it. We have the activation, and we also have the selection. I'll select number 3 and let's test this system out. So yep, the unit has been ejected out. The flying machine is coming by. In anticipation, will we see the horse appear? We will! Perfect! And then we can just ride the horse out, and then let's see if we can deposit the horse. It goes back down. Well, it slides down a honey block for some reason, I don't know why. Let's see. Nice. And then, yep, number 3 is back. We have a horse in number 3. That was a perfect test. Thank you for watching. Oh shit.